One way that you can easily graph polynomials of higher exponents or higher powers is to check your graph. You can use a website I use a lot. It's called www.desmos.com, DESMOS.com. It's a free site where you can plug in your functions and find all of the necessary information like intercepts, all local or relative minimum points or maximum points. So I've already typed in number 59, and Desmos has a handy keyboard that you can use to type in higher degrees. So let me minimize this list. And you may have to zoom out quite a bit. You can already see where the intercepts are. The x-intercepts, I should say. You just click on with your mouse, and you can see immediately what the x-intercepts are. And then you'll have to zoom out quite a bit. Because we know this is an odd, the highest degree is an odd power, we know that our graph is going kind of like a roller coaster, either up, down, and up, or because our leading coefficient is negative, then that means our graph is going down the roller coaster, up again, and then down again. So we can use this to find our minimum points. There is a relative minimum point right here, I believe. So the minimum point occurs at the order pair negative 4.737 roughly to negative 27.034. And let's see if a maximum point exists. And here's a local maximum point. And it happens at the order pair 0.84. And that just happens to be your y-intercept for the function, or where the graph or the function crosses the y-axis. So Desmos is a pretty neat website to use to find all of this information. Let's look at another function. Number 63. We have 2x to the fourth power plus 3x cubed minus 17x squared plus 6x, minus 6x minus 72. Make sure I type that in correctly. Now, anytime you have a function with an even highest degree, like squared to the fourth to the sixth, then it'll form probably a graph that looks like a regular size U. Or if your leading coefficient is negative, then it would be called concave down, or in other words, the cup is upside down. But since our leading coefficient is positive 2, then that means our function will be concave up, or the cup is full. So let's identify our x-intercepts. the x-intercepts happen right here at -4, 0, and also the order pair 3, 0. Now, because our leading coefficient is positive and our graph opens up like this, then that means down here where your vertex is, that's actually a minimum point. So let's scroll all the way down till we find a minimum point. And actually, x to the 4th has several minimum points. There's one right here. So that would be relative min. And another relative minimum point happens right here at the order pair 1.677 and -99.904. Now, some other information that we can find. Our relative maximum point occurs right here, I guess. So that would be our relative maximum point. And then right next door to it is your y-intercept, or whenever x is equal to 0, then that indicates a y-intercept. So you can use Desmos to definitely help you find all of this information for a polynomial.